Hi everyone, welcome back. Today we're going to work on a topic called classifying the lung CT scan images. That is, they are not 2D images, they are 3D images. Lung CT scan nothing but they are like COVID images. We are going to work on them and we are going to classify them. Till now, you will be knowing how to classify 2D images, how to access them, how to pre-process them, and how to use them as a data for your models and train the models. But now it is not that much easy when you need to work with multidimensional images, that is especially 3D images. So how we gonna do that? Okay, initially I will show the result. Okay, whenever you feed any image, finally we can say like how much percent that belongs to normal and abnormal. As it happens in every other classification model, we can say like one of the image I feeded here from the testing dataset or validation dataset. So I get the result a 79% possibility that that belongs to abnormal because that image was abnormal. It's saying like this, and you can see the graphs here. Okay, the thing you should keep in mind is that I trained only for 20 epochs, and accuracy I am getting around 61 validation accuracy, and training accuracy 75, but 20 is very less. Okay, you need to train till 100 epochs, minimum 100 epochs you need to keep it, and you will get above 86, 87, or nearly 90 and 90 above sometimes. Okay, you will get like that good accuracy. Yes, I will start to discuss from starting point. Okay, initially we are going to import all the libraries which are required. Again, I'll just give a little explanation about all the libraries. First one is OS, operating system. This is used to access any files from your system or any components from your system. To access that, we use a library called OS. And then comes a library called zip file, which is used to extract the zip files using Python. Then comes NumPy. NumPy is a library that is used to work with arrays and matrices. Then TensorFlow. The part of TensorFlow, Keras and Keras layers, the three libraries are there, no? Better I will explain them below. We will use them below during building a model, so you will understand it very well there. First, what is our main aim of this project? So here we need to first take these 3D images, we need to read the images, we need to train a model from the features of these 3D images, then we need to test it and get a better accuracy. It means, to keep it simple, it is to classify CT scan images is our main aim. And about dataset, I already provided you the link here. Okay, from this site we are going to get the dataset, or from Kaggle also you can get the dataset. This is the main source of that dataset. Okay, it is available in Kaggle. Otherwise, here I gave a link. From URL you can directly download the dataset. Okay, this is the best way actually, instead of downloading it from Kaggle or like that. Directly using this link you can just directly download it. Okay, now once you download that part, okay, there are two files. One is for CT scan 0, CT scan 23. It means CT scan 0 nothing but it's healthy person. Okay, it means no problem like scans. Okay, the second one is the scans with problems, or there is some distortion in the scan images, or maybe is got affected with COVID, like that we can say. First one is without COVID, second one is with COVID. Now what we need to do, once we download that, they will be in zip format. Okay, now we need to extract that. Okay, for that we are going to extract those two folders in a subfolder called mouse metadata. It means uh, this is called this is a file where these two sub files are extracted. So we are going to extract and keep that. Now we have proper image data set. They are not in normal format. Okay, they are in n11 sorry nii.gz. we call this format as a different one. Okay, this is not a normal image format. Okay, for that what we are going to use is, here you can see, nifty format with extension n.nni. Nifty format we call it. Okay, for this what library we are going to use? Okay, nibble package. Okay, this library is used to read like this particular images. Okay, you can install this using pip install nibble. And one thing you can do is, this is not only used for only this format, there are so many other formats. For that you can use nibble. Okay, the pre-processing thing, what we do is, first we will try to rotate the volumes, nothing but they call them, sorry, we call them as a volumes, but it is nothing but images itself with 3 dimension. We call it as a volume. First we will try to change with orientation and HU. You maybe know that there is not only RGB, there is HVU, sorry, like that there are so many other color formats are there. Okay, and so we are going to play with that, and we're gonna resize width, height, and depth of image to our interest. Okay, for that we have code below. I will explain you once. Okay, before that, I'm trying to make two lists here. One list which contains complete image paths of good images, and another list which contains complete image path of deceased images. That's what I am doing here. Okay, in these two lines, and I'm printing those two lists to just see. And how many images they are having? They are having 100 images for each list. One is normal scan path, it means normal images complete path, and the second one is images path with abnormalities, or say COVID affected. This is the link where you can install that nibble library, and you will get much more information about that. Okay, this is used to work with all these type of extensions, not only nifty, like which we are using nii. Okay, if you have some images with minc, afni, like that, medical images or some other images which is having different extension, in that case also you can use nibble. Okay, and SciPy is also used to read multi-dimensional arrays and work with multi-dimensional arrays. So here, with combination of nibble, when you import an image with nibble, it will be multi-dimensional array. So, but how you need to plot it, map it, or like that. So to do that, we try to use SciPy library and a function called image, n-dimensional image, which indirectly says. Okay, this function we are going to use to plot the images. So now our pre-processing, what are the pre-processing steps we do? I will explain it. Okay, here you can see. Now what I will do is, I will call a function called process scan of path nothing but abnormal scan path. Okay, what is abnormal scan path? Abnormal scan path is a list which contains complete path of all abnormal images. Now I am taking one by one all the paths, and I am feeding that to a function called process scan. Then what will happen, and whatever the result I will get, I will convert it into numpy array. It means all the 3D images I will push to one processing function. When I get output from that processing function, that output I will convert it into an array. So that will be abnormal scans array. Okay, this will be that array. So now what we need to see is, what is this process scan, what this function do. Okay, we will try to reverse engineer the stuff here. Okay, we will go back one by one what it will do. Okay, so first, when for example path, in fact, take one image. Okay, one image will come one by one, all the images will come. No, so take first image is coming, it will go to process scan function. It means it will come to line number 57 as an input. Now when it comes to this function, first what will happen, it will be pushed to another function called read nifty file. What is this function? Where is it? It means that path will be pushed to this function. This function will be here, read nifty function. What it will do, it will read that using nibble library, and using that, and it will get the data, nothing but get the complete array, as you can see here. Okay, I'm plotting it for one of the image. Okay, how it will be there after reading. Okay, that it will read using nibble, and that array, okay, whatever the array it got as output from nibble, it will be sent to next function. What is that next function? It will normalize the value. What is meant by normalizing? For normalizing, I have a code here. Okay, here what we gonna do is we gonna try to normalize the values. Okay, we are saying, okay, if something is okay, for example, if that volume size is less than minimum, okay, it will be minimum. If the maximum greater than maximum size, it will be maximum. So we'll try to keep that as a average, nothing but some value comes. Okay, its array values will be maybe like it will range from 1400 or some 256, like that some value will get. But we'll try to divide that whole thing. Okay, first we'll value minus minimum value minus 1000 will do, and max minus minimum will do. It means 1400 divided by 1400 directly. Okay, like that we'll try to do. Okay, and return the value. It means our data will not be having huge numbers now. Okay, our data will be having a number which is less than 1400, like that. Okay, here that will be normalized. So then what we are doing, we are pushing that whatever the array we get, we are pushing that array to resize volume function. Where is that resize volume function? Here. What this gonna do? Okay, here we are trying to set the size, or that is height, width and depth, to our interest. Here you can say desired depth, desired width, desired height. Okay, anyway, initially you will get image, shape, height, what is there actually. Okay, and after that we will divide that with our interested values, and after that we will take that as a depth factor, height factor and width factor, and we'll try to resize that using ndimj. ndimj is a library of sci-fi. Using that we'll try to resize that image, and we'll get that image as an output. Okay, these are all three pre-processing function we did on this, on each images. Now one is we will read the image, next we will normalize all the pixel values okay, in 3 dimension, and after that we will resize that according to our interest. Okay, these three are done, and that image will be returned. Okay, after pre-processing all these things, that will be returned out. That value will again be converted into array. Okay, now in the same way we do it for normal scan path also. Same thing will happen. Now here we are labeling the data. What we are doing is we are trying to assign one for normal, for normal 0, for abnormal we are going to viral pneumonia, nothing but just like a COVID. Okay, COVID and pneumonia are very different, I know, but if you get the data set of CT scan, they will almost be same. Their effect on the lungs will be in the almost same way. Okay, that's what I'm trying to say. Okay, that's all. So here we are assigning, we are creating a label, we are creating an array which contains, okay, a full 1111, like that. For normal scans it will be 0000, like that. You will be having 2 arrays. Now next step is splitting the data set. How you will split the data set, and what are the parts you need to split? You need to split it in 4 types. One is four parameters. One is training input, training output, testing input, and testing output. Here for that, what I am doing is I am taking abnormal scans till 70. Okay, that means I am considering 70 images, and I am taking 70 from normal. Okay, in the same way, for white train, nothing but what happens, the label list I am taking 70 for train, sorry, 70 normal and 70 abnormal. Okay, for validation I am taking 30. Okay, normal 30 and abnormal 30 images, normal 30 and abnormal 30 labels. So I am making it as a concatenating, nothing but joining that. Okay, you may be heard of batching. In the same way the concatenation works. Okay, batching nothing but summing up both of them and making an array. In the concatenation also it's almost same, concatenating or joining two arrays. Here I am trying to print that shape of the array. Finally, what I actually want, okay, we need to know the we need to convert into some data loader stuff or like that. So I'm taking xtrain and ytrain and I'm loading that as a tensor slices, and I'm calling it as a train loader, and for this I'm calling it as a validation loader. They are nothing but batched data we can say from tensor slices, nothing but it also exactly works like that. If you want much more about this, we'll visit their website itself. Yeah, one thing to show you is that so many people are watching our videos, but the stuff is 95.9% of people are not subscribing. Only 4% of people are subscribing our channel. I don't know why. If so many people are watching, if it's somewhat useful for you, you can subscribe, I think so. Yeah, that was the thing. You can subscribe, no, if you like the video, if you feel it like this was useful for you. Okay, that's fine. Now I am setting batch size. Here I am taking batch size as 2, but you can increase it. Here I have only 100 images for both of them, and even I am splitting 30 for validation and 70 for training. I'm keeping it very less. You can increase it. By increasing batch size, the possibility of getting more accuracy will be there. So after that, now what we need to do, using sci-fi and we are trying to rotate that value nothing but that image to some random angles. Okay, like this particular angles, and we are trying to uh, plot that. Okay, that you can see here. We are not doing anything. Okay, we are reading some image. Okay, whatever the input comes here, we'll read, we'll rotate it, and we'll return that. Okay, we call that as an augmented image. It means what is nothing but augmentation. It's like, for example, if there is an apple and you are showing it to me in one side, okay, that is only one wave. If you are rotating and showing it to me in multi-dimensional, okay, this way and all the possible angles, then I say you are augmenting the same image. The first image what was there, you are showing the same image in different orientation. We call it as an augmentation. Okay. Now the stuff comes here. For train and validation, what we are doing, okay, what was the pre-processing is there, no, train pre-processing and validation pre-processing. What are they are these two functions. Okay, what they are doing, okay, they are using rotate function. For what they are rotating, they are rotating volume and label. Which volume and label? Which we already done during pre-processing. Pre-processing we've done so many things, no, resizing and all those stuffs. Those data it will take and they will try to augment the data. By augmenting the data, why we need to do augmentation? Nothing but to increase the size of the data set, we do the augmentation. Here we are doing augmentation. The augmentation here is only one thing, that is rotating. There are so many other augmentations, maybe change in color spaces, or change in its flipping, transposing. There are so many other augmentation, but for 3D images it's better to change the angle itself. Okay, by augmenting the data we are increasing the data set, and we are calling it as a trained data set, augmented data, validation data set, that augmented validation data. Okay, and after that we are plotting one of the image from that. Here you can see what we are plotting is, we are taking the train data set label first. Okay, train data set, from that train data set we are taking one, nothing but the image, and we are trying to read that, and it will be having two features. One is, first one will be image, second one will be label, because that is concatenated data. As you saw above, concatenated, it means they will be attached together. First one will be image, second one will be label. I will read that image array, okay, image.numpy, and I will try to plot that using matplotlib, that is plt.im show. Then I see this image. In the same way I am doing it for some number of images, slices I am doing it, same reading the image. Okay, I'm not doing anything, I'm trying to read that. Okay, while I am reading, I am trying to rotate it with some 90-degree, and here I am trying to transpose and resize the data, and I'm just taking that away, and I am trying to print some values, some images here down. Here I am not doing any special thing. Here just this is just a plotting thing. Now you need to build a model. For that, what I am doing, here I am taking whatever the input I will get, then I am building a stack of layers. This is basic layer. Here you can use your own model in the case. Okay, maybe like well structured models, maybe ResNet, like that. Okay, if you have plan of using some good models, if you can use, or if you face any problem, let me know, I will try to help you. Okay, here I used only basic stack of layers like convolution, 2D, maximum 2D, and batch normalization. And after that, you can print out the model. Okay, CNN model, whatever the CNN model you build, you can use, you can plot it. Then you need to train the model or compile the model. Before going for training, you need to compile it using some values. For that, learning rate I am taking 0.001, which is like a standard stuff. Almost using this we'll get better values. Now we are setting optimizers. Okay, so here you may heard about Adam optimizer, Adagard optimizer. In the same way, there are some optimizers where you can express in-depth parameters very clearly. Say one of them is exponential decay. Okay, more about this we'll see here. Oh, due to some problem I am not getting. Okay, this one of the optimizer. Okay, this is used to reduce the losses. Optimizer will always help us to reduce the losses, or like that. Okay, using this we are setting a LR schedule. That LR schedule we will use for our with our Adam optimizer. Okay, learning rate, that is learning rate you can directly take this only, 0.0001. if you want to take, you can take, no problem at all. Otherwise you can take, or you can define it. Okay, LR schedule, this is nothing but learning rate. Okay, you are setting a learning rate for Adam optimizer, and what you are doing is what type of loss you want to print during the training. binary cross entropy. Why you are going for binary cross entropy? Because you have only two classes. Okay, otherwise you could have gone for RMSC, categorical cross entropy, MSC, like that losses. Then comes matrix accuracy. Okay, it will give us a accuracy value. Now you need to define another thing. All these checkpoints should be saved in the name of 3D image classification.h file. Okay, early stopping you can define, or without using early stopping is a better way. What happens with early stopping is it will see validation accuracy. Okay, if there is a 15 epochs where that is not changing validation accuracy, it feels like it's not changing a lot, it will try to stop before 100th epoch. If you are doing 100 epochs, it may stop at 40-50 epoch. So better way is try to remove this callback, early stopping and from callback remove this early stopping stuff. We don't need early stop. Okay, run only this much, and you need to keep this epoch to 100. Okay, I made it only for 20 because of the time. It takes a lot of time. Okay, you can make it 100, then you will get good accuracy, nearly 90% or like that. Okay, it's a lot because you have less data. That is the stuff you need to keep in mind. You need to have minimum of 1000 data for each classes normally, but you have only 100 images. Okay, that are not enough. Even then also you are getting good accuracy. Like initially validation accuracy was very less, then it raised, and it was nearly more than 60% for 20 epoch. If you do it for 100 and 200 epochs, it will be validation accuracy will be more than 80, and training accuracy will be nearly 90 or like that. Loss is also very less when you compare, and if you train it for more epochs, it will also reduce. Then what we do is, now I'm using that saved model here, and what I'm doing is from X validation I'm taking one image data and I'm feeding it to my model. Then what I'm getting after prediction, it will give me that array. It contains, okay, 20, 0.20, 0.79. I'm multiplying it with 100 and I'm printing it. Okay, this percent possibility that it belongs to normal, this percent 79% possibility that it belongs to abnormal. And you can customize this. It means instead of np.expand of dimension of x value 0, you can feed your own 3D image as an input. That I'll be explaining you in the next video, and you can make it as a user interface in further steps. Okay, this was the class, and we'll see in next class where we'll be making improvement over this. We'll be making it as a user interface in further videos. If you comment it, then only I will work on it, otherwise I will work on new topic. Okay, whoever want a user interface over it, comment it down. If you like this video, just like and subscribe the channel. Thank you.